In this video, we're going to be talking about writing solutions to a 3x3 system of linear equations from augmented matrices. Okay, so to get a unique solution out of a 3x3 augmented matrix, it needs to look like this. You need to have ones on the diagonals right here, zeros everywhere else, and then numbers over here. These could be positive, negative, zero, whatever. Okay, so if you get something like this, that's good. That means x equals this number, y equals this number, z equals this number, assuming you're setting it up with x, y, z. Okay, when you get no solution will still look like sort of like this matrix, except you'll get something that doesn't make sense. Like if your bottom row looked like this: 0, 0, 1, 2. Okay, or actually 0, 0, 0, 2. So that would be saying that 0 is equal to 2, which is not true. Okay, because there's no 1 in a placeholder for the variable, so 0 is not equal to 2. That would be no solution. Okay, and if you got infinitely many solutions, that means one of your rows is going to be straight up zeros. Okay, so that would be infinitely many solutions, and that gets written in a special way. Okay, so let's take a look at these 4 problems and see which ones we have. Okay, so for the first one here, we've got this 3x3 augmented matrix. This will be our x column, our y column, and our z column, and this will be where our answers are. Okay, so this first row says 1x, or just x, plus 6y, there's no z because there's a 0 there, equals 1. Okay, and our second row, there's no x, there's no y, but there is a z. Z equals 6. Okay, and then the last one, 0 equals 0. So this is going to be one of the ones that's infinitely many solutions. And what we have to do is figure out how we want to go about writing this solution. So we have to make a decision. We need to figure out whether or not we want to put everything in terms of x or everything in terms of y. Both ways are correct, but usually when you have 2 different ways of doing things, one way is usually going to be easier than another. So I am going to do both, and we'll see which one turns out to be easier. So I'm going to put answer in terms of x first. Okay, so if I'm putting my answer in terms of x, that means when I write my solution here, which I'll have 3 things in here, then x is just going to be x. So x is equal to x. We're putting our answer in terms of x, so that's our starting point. Okay, and then we need to put the other things in terms of x, unless it's already got a solution. So we already know that z is equal to 6 on this problem, so we can write that down. So the only one we're looking at is this middle one, this y, and since we chose to put everything in terms of x, we need to solve this thing for x. Okay, so actually we need to solve it for y and get x on the other side. Okay, so on x plus 6y equals 1, we're going to subtract the x from both sides, so that will give you 6y equals 1 minus x, and then you could divide the 6. Okay, so that will give you 1 minus x over 6. Okay, so that's one way of writing the solution. We could also put our answer in terms of y. Okay, so if our answer is in terms of y, then y is just going to be y. Okay, 6 was also given, z is equal to 6, so we can write that down still. But this time, since we're putting our answer in terms of y, we need to go over here and solve this thing for x. Okay, so if we solve for x, it'll put x in terms of y. So if we have x plus 6y is equal to 1, we subtract the 6y, and we get x is equal to 1 minus 6y. Okay, so these are both correct solutions. Okay, now I'm going to show you that they are actually the same solution, just written in a different way. Okay, so first let's do this one, and let's substitute, and let's say x is equal to 1. Okay, we'll call this answer number 1 and answer number 2. Let's substitute x equals 1 in there. So x equals 1. We would need to plug it in here as well for our y. So y is equal to 1 minus 1, where the x is, over 6, which is 0. So you get y is equal to 0. And then z is equal to 6. So you get the solution 1, 0, 6. Okay. Now let's go to the other one, this 1 minus 6y, y, 6. And let's start with y is equal to 0. And let's see if the other two, the x and the z, turn out to be the same as this. Okay, so I will make y is equal to 0 because that's what the answer I got here. So if I make y is equal to 0, I still know that z is equal to 6. That hasn't changed. But what about the x? X is equal to 1 minus 6 times 0, so x is equal to 1. So we get y is equal to 0, z is equal to 6, and x is equal to 1. So 1, 0, 6. So it works. Okay, so if you, in the first one, you would need to start with an x value and then put it in here to find your y value. In the second one, you'd need to start with a y value and put it in here to find your x value, but you're going to get the same answers every time. Okay, so either way, either one of these answers is correct. All right, let's take a look at the next one. So on this one, we've got x. Remember, this is x, y, z. X equals -2. So far, so good. We got y is equal to 5. And then on the last one, we've got no variables here because there's no 1s. So we've actually just got 0 is equal to 3, which is not true, right? This is not true. Thus, no solution. Okay, so for that second one, we get no solution. Okay, let's do this one. So in this one, if we write down, get another piece of paper, if we write down what the equation is, it will be 1x, or just x, minus 2z, this is a z column, so minus 2z equals -7. And then we get y plus z equals 3. And then on the last one, they're all zeros. So we don't write anything down, but we know that this means that there are infinitely many solutions. Okay, so again, we're going to have two different ways of writing this answer. We can put it in terms of z or put it in terms of y. Okay, so let's see. Let's try putting it in terms of z first. Okay, so if that's the case, then z is equal to z. Okay, since we weren't given z is equal to a number, we'll just say z is equal to z. Okay, so on the first one, put a z here. Okay, and now we need to put x and y in terms of z. Okay, so let's solve y right here. Let's solve this for y. So we move the z over, so y is equal to 3 minus z when we subtract that over. So that's what y is, 3 minus z. Okay, let's do the same thing with the x. If we add the 2z over, we get x is equal to 2z minus 7. 2z minus 7. Okay, so that's infinitely many solutions, and we could plug in anything for z and get values out for x and y. So let's try z is equal to 3. Okay, so if z is equal to 3, let's figure out x. X would be equal to 2 times 3, 2 times z, but we're using a 3, minus 7, that's equal to -1. So x is equal to -1. And now let's figure out this one. Y is equal to 3 minus z, but our z is 3, so 3 minus 3 is equal to 0. So you get the three solutions for x, y, z, -1, 0, 3. Okay, so that's a solution if you start with z is equal to 3. You can start with whatever number you want. Okay, the other way of doing this is to put everything in terms of y. Okay, so if we put everything in terms of y, we'd have y is equal to y. Okay, so that would be written like this. We just put a y in the middle. Okay, and then we need to put the other two things in terms of y, right? Okay, so the first one's pretty easy. We can use this one right here, y plus z equals 3. we can just move the y over. Okay, so z is equal to 3 minus y when we subtract it over. So 3 minus y gives us our z term there. Okay, for the x term, it's going to be a little bit more involved. We actually need to, well, we're going to use this equation, x minus 2z equals negative 7. But if we use this directly right here, we've got no y, and we want to put it in terms of y. All we have is a z. But that's fine, because we can use this and plug it in right there and make it in terms of y. So it would be x minus 2 times 3 minus y equals negative 7, which is x minus 6 plus 2y equals negative 7. Now I can solve this thing for x to put it in terms of y. So move the 6 over by addition. So we get x plus 2y is equal to negative 1. And then move the 2y over, so x is equal to negative 1 minus 2y. Negative 1 minus 2y. It's another way of writing infinite solutions to this problem. We just put it, instead of in terms of z, we put it in terms of y. Now, to prove that this works, I'm going to use the y value that we got for this one when we plugged in for z. We got y is equal to 0. So I'm going to use 0 here and see if I come out with a negative 1 here and a 3 here, which we should. Okay, so I'll plug in a 0. So 0 in here, negative 1 minus 2 times 0. That's just negative 1 because the y term goes away when you plug a 0 in. Okay, so negative 1. We know that we're starting with y is equal to 0, so we know that one's right. So the last one, we plug in a 3 here, or actually plug in a 0 here, and we get 3 minus 0 gives us 3. So we used the y as a solution, but it still gave us the same 3 x, y, and z. Okay, so either one of these are correct solutions. All right, let's do this last one. So on this one we have, let's see, x, there's no y, there's no z, so x is equal to negative 3. On this one we have y, there's no x, no z, so y is equal to negative 8. And on the last one we've got no x, no y, but we got z is equal to negative 1. So our solution is negative 3, negative 8, negative 1. So that one does not have infinitely many solutions. That just has the one solution.